Hello everyone. In this video, I will be discussing about LeetCode problem number 3840, that is house rover 5. So first of all, let us read the problem statement. You are a professional rover planning to rob houses along a street. Each house has a certain amount of money stashed and is protected by a security system with a color code. You are given two integer array nums and colors both of length n, where num size the amount of money in the ith house and color size the color code of that house. You cannot rob two adjacent houses if they share the same color code. Return the maximum number of return the maximum amount of money you can rob. And the constraint is in can go up to terrace for 5 and num size and color size can also go up to terrace for 5. That is, let us see with an example. So in the input you are given an nums array and colors array, where color array denote the color of the ith house and nums I denote the amount of money present in the ith house. And there is a rover that has to rob some houses, but there is a condition. If the color of two adjacent houses is same, then he cannot rob both the houses. Still, he can rob any one of the houses, but he cannot rob both adjacent houses. So, for this example, as you can see, the last two houses color are same. So, the robber can rob only one out of these two houses. So it is better to rob the last house. In- because if you rob this one, then you have to skip this one, and if you rob this one, then you will have to skip this one. So either way, we have to skip one of the house. So it's better to skip the smaller one and take take out the larger one. And since these two house color is not same, so we can rob both of the houses. So from this, the answer will be just 4 plus 1 plus 3, that is 8, and the answer is also 8. Now let us see the second example. In this example, the first two house color is same and the last two house color are also same. So out of these first two, we can rob only one. The robber can rob only one house, and from the last two houses, the robber can rob only one house. So it's better to rob this one and this one. So the answer will be just 4 plus 5, that is 9, and output is also 9. And let's see the third case. This is an important test case, so please mind here. See, the first three houses color is also same, so we can rob any two of the house, because see, the color of first three houses are same. That does not mean you can only rob any one house. In the problem statement, it is saying that you cannot rob the adjacent houses which have same color. It is not saying that you can rob only one house. If there are many houses with same color, then you can rob only one. It is not saying like that. It is just focusing on the adjacent element. So if you decide to rob this one, then you can still rob this house. That is, if you decide to rob first house, then you can still rob the third house, because first and third are not adjacent. But if you decide to rob the second, then you cannot rob the first as well as you cannot rob the third one, because these both houses are adjacent to first one. So either we can rob this one and this one, and obviously you can always rob the last one because last one color is not same. But out of these three two, either you can rob first and third, or you can rob just second. So it's better to rob the first and third and the last. So this way our answer will be 10 plus 3 plus 9, that is 9 3 12, 12 10 22, and the answer is 22. I hope the problem is clear now. So, so now our main focus is on the approach, how we can approach this problem. So let us see. See, in the optimal solution, we can rob some houses and we can skip some houses. But just by looking at the array, we cannot say which one to rob and which one to skip. Like you cannot go with the greedy approach. Suppose let's take an example, and colors are also also same. So suppose you decided to pick this one because is because out of these two this is larger, so pick this one, and you will have to skip this one. And if you decide to pick this one, so you will have to skip this one. But if you do so, answer will be 12. Hmm. But there can also be other way which will be optimal, like just pick this one and skip these two and pick this one. So in that case, answer is 20, which is better than previous one. So the conclusion is that in the final answer, there will be some houses which we have to skip, and there will be some houses which we will have to pick. The only condition is that two adjacent houses, if you are picking those two, then color should not be same. So mm, so the best way to go with this, just try all possible ways by picking and not picking some houses. All possible ways means we have only for each houses we have only two options. Either we can pick it or skip it. That is, either for this house, either we can pick it or either we can skip it. Similarly for all these two. So we can go with this. Um, we can write a simple recursion, like let's say our recursive function is f, which is taking an index I, and second parameter is we are picking the ith item or not. And let's say this variable is p. P can only hold 0 or 1. 0 means we are skipping the ith element, and p and 1 means we are taking the ith element. And what it will return? It will return the maximum amount of money the robber can rob up to index I, such that if p is 0, that means he is skipping the ith element, and if p is 1, that is if he is taking the ith element. So formally we can write a we can define our states such that f of I comma 0 will return max amount of money the robber can rob till index I, such we skip the ith house. Similarly, f of I, comma 1 will return the maximum amount of money such that he pick the ith house. And what will be our final answer? So our final answer will be maximum of both ways, that is if you are taking the last element, you are skipping the last element, and you are taking the last element, whichever will give the maximum money, we will go with that. So now this is our state, this is our final answer, and what will our transition? So transition will be for skipping the ith element. If you are skipping the ith element, that means you have only two choice. Either you can pick the previous element or skip the previous element, and whichever will give the maximum, we will take that. So it is simple, just maximum of f of I minus 1 comma 0 and f of I minus 1 comma 1. And obviously we are following top down approach, because we are going from larger index to a smaller index. And for if I decide to pick the ith element, then in that case, if you decide to pick the ith element, let's say a1, a2, a3. If you decided to pick the ith element, let's say I will have 2, then in that case, we have two options. Either we can take pick the previous element or skip the previous element, but it depends on if the color of the both houses are same or not, because in the skipping case color doesn't matter, we can always skip the house. But if you are taking, it depends on the color of the house. If the color of both houses are same, then we have definitely have to skip this. If they are not same, then we can pick this. We can either pick this or skip this, whichever will give the maximum, we will go with that. So formally we can write this: if color of ith equal to color of I minus 1, then we definitely have to skip the previous element. So in that case, it will be simply just nums I plus f of I minus 1 comma 0. But if suppose color is not same, then in that case maximum we can get by just we can skip or pick the previous element we have chosen. So we will take the maximum of these two, that is f of I minus 1 comma 0 and f of I minus 1 comma 1. So for this state there will be two transition depending on the condition, this one and this one. And if we are skipping the ith element, then we have just simply one transition. And this is our final answer. And this is our state. So yes, this is the coding. This is the solution. Now we should now we can move to the coding part. So let us see. Now let us see the coding part. So first of all, we will see the brute force recursion way, and our recursive function will return the maximum amount of money, that is long, and if which will take two parameter. First one is index, and second is either we are picking the ith element or not. And obviously we will have to pass this nums and colors vector as well. So we can declare this as a reference because we can't bear the cost of copying the whole vector each time. So we will have to pass as a reference for efficiency. And our p is equal to 0. Then we can simply return the maximum of a power 5 minus 1. We are skipping the ith element. That means we can skip or the previous element. And else is if p is 1, then there are two cases. If color is same or not. Colors of are equal. If colors of both current and the previous is same, then and we are picking higher element. That means we definitely have to skip the previous element. Then simply we can return 0. This we have already seen in the explanation part. So here we don't need that much to explain. And if color is not same, then we can return x of we can either speak the previous, skip the previous, or pick the previous. And what will be the base case? This base case is simple. If at any point of time we are getting out of one, then we can simply return 0. And one condition is also if our I is 0, then this here we will get defined variable. This will go out of bound current vector. So it's better to handle 0 case as well. So if I is 0 and we are taking the ith element, so and that's written multiply, because if we are at the first element, then we have only one choice. We can definitely pick the current element, and there is no previous element, so we don't have to. We don't. We are not dependent on the previous element. So this is a recursive function. Now we can just store the node size. We are just storing the length of numbers and return maximum n minus n0. Return this. This approach is passing for 79, almost half of the cases. Now we can simply minimize this recursion and pass another parameter as d. dp of phi is not equal to -1 just dp of phi. So, okay, okay. Actually, we have let's make all this a long but these two must integer because the integrated compilation error if we change into longer is to we can just copy here the problem again. DC temporary. So finally getting accepted. This is recursion plus memoization. You can also, if we want, we can also write the tabulation for. Let's write the tabulation for as well. Let's just comment out this one. Really similar. Initialize dp of 0 with 0 because we are skipping the first element, the answer will be 0, and if we are taking the first element, this will be first non-zero. This is basically bottom-up approach, and this and the nth one is top-down approach. So we are bottom-up, we are going low to high. Let's I not connect to colors of one minus then degree I one 0 millimeters plus 4 minus 1 and the last s- yes. So this is our recursion plus JSON, and this is tabulation relation without space optimization. Now we will see tabulation with space optimization. See, our current state is depending on just previous state, and previous of two types. Either we are picking or skipping. So for this we can just declare two variable, that is for previous. Let's say P means we are picking the previous element, and NP means we are skipping the previous, not picking the previous element. And for and we can calculate the current one as for if we iterate from 5 to 1, from 1 to n, then our previous we are picking, then in that case it will be minus 0, and not picking simply 0. So that we are iterating from index 1, so that we don't have to take care of the out of bound. Then we do minus 1 in the index. So our if we pick the current element, then what will be the answer? It will depend on the whether our color is same or not. color of the ith house is same or not with the previous. So if check if color is same, then in that case if we pick the current element, then we have to skip it will be just skip the previous element. So this is only one way. If color is same, then we have only one option. Color is not same. Let's actually we will access the C variable later. So just define even the equals block. And if color is not same, then we have two options. We will take the maximum of peak and not. And if we and other is if we skip the current element, in that case skip the current element that is not taking the current element, then our answer will be just maximum of common element. Now at last we have to just update the P and NP variable. That is P will become C and NP will become, and lastly we will return the max of P comma NP. Yes, this is the fastest solution I guess for tabulation with space optimization. So overall we have seen three solutions. First is recursion plus memoization. Second is tabulation without space optimization. And the last one is tabulation with a space optimization. Now let's see the time. Now let us see the time and space complexity of each approach. So for this one, time complexity will be, in total we have 2n states and transition time is constant. So overall time complexity will be linear, that is big of n, and space complexity will be, we have recursion stack space and dp vector and two other vectors. So overall it will be linear as well. So this is the time and space complexity of this approach, that is both are linear. And for this one without a space memoization, TC will remain the same, that is linear, and a space complexity will still remain the same because we are still declaring 2D vector, and 2D vector which will take linear space as well. And for this TC will remain the same because we are iterating the array, and SC will be big of 1. For the see for all the approaches time complexity will be the same, but for the last approach space complexity will be constant. And yes, so this is the complete solution of this problem. I hope this video will help you something. So thank you.